Hello. Hello. Am I audible? Hello. Hello. Am I audible?
Yeah, very good afternoon to everyone. Welcome to the International Conference on Advances in Science and Engineering and Technology 2024, and thank you for joining us today. My name is Dr. Archana Yadav, Assistant Professor from Department of Electronics and Communication Engineering. Today I have the privilege of being your session moderator for this session. Now I would like to introduce our session chair, Dr. Harsh Devsam from BBD University, Lucknow. Now I would like to, so I want to extend a warm welcome to all our participants joining us both in person and online. So our first participant is Mr. Salman Ali. Mr. Salman Ali, you can unmute yourself and start your presentation. And please keep in mind, you are given only 10 minutes for the presentation. So try to wrap up within this 10 minutes. I also welcome to I also welcome Dr. Meera Agrawal ma'am, who is also a session chair for this session. Welcome ma'am and welcome sir. Mr. Salman Ali, please start the presentation.
Yeah, you all are kindly welcome for this session. Paper ID 210 and other speaker, please make sure you have 10 minutes, 7 minutes for your presentation, and last 3 minutes expert will give you question and answer and suggestion. Thank you very much. Mr. Salman, yes, you please, you are not audible. You are audible, but your voice is so slow. Paper ID 210. Mr. Salman Ali.
Mr. Salman Ali, unmute yourself from your side. Mr. Salman Ali, can you?
Okay, आप उनको कॉल कर लीजिएगा नेक्स्ट प्रोग्राम.
नेक्स्ट है रवींद्र जैन. ये ऑफलाइन या ऑनलाइन का कोई स्टेटस नहीं है यहाँ पे.
Mr. Ravinshu Jain is there.
सलमान अली आ रहा है.
Paper ID 201. Okay, paper ID 3210. Mr. Salman Ali.
Mr. Salman Ali.
Mr. Malik Sajjad Ahmad Iqbal.
Hello. Hello. Am I audible?
Yes, sir, you are.
Okay.
Mr. Salman Ali, paper ID 210.
Salman Ali. Not looking for it. Even Mr. Ali.
Thank you.
हाँ फिर से कर रहा है.
मलिक साहब को कॉल करता हूँ, वो अवेलेबल है. इनको आप इन्फॉर्म कर दीजिए कि इशू सॉल्व करके आए. हेलो. मिस्टर मलिक शहजाद अहमद इकबाल. हेलो.
Hello, am I audible?
Yes, please share your screen. Thank you.
Thank you for unmuting.
Please share your PPT.
Yes, sir. Sir, my PPT is visible?
Yes.
Good afternoon, everyone. My name is Malik Shahzad Ahmed Iqbal. I am a research scholar in the Department of Computer Science and Engineering in Trivandrum University,
Okay.
Lucknow.
Please share your
My
PPT.
talk,
Yeah, presentation PPT that is not shared.
it is not visible, sir.
I think still some issue. Please share your PPT. You shared schedule of the conference.
No, I shared already. I am sharing again, sir. Give me 1 minute.
ओके जस्ट वेट स्क्रीन में यहाँ पे तो नहीं शेयर होगी यहाँ पे तो ये है नहीं
Can I share it again, sir?
Please share your screen.
प्लीज शेयर योर स्क्रीन
Yes, I already shared. Is it visible, sir?
नो
I already shared. It is showing as a sharing. Should I stop sharing again? Mm, share entire screen. Yes. Is it, sir? Visible?
नो सेम प्रॉब्लम
Here it is showing that it is a shared, sharing your screen.
Sir, till then, what we can do, we can go for the next participant so that in the meantime, we will be able to rectify the problem.
Mr. Salman Ali. Mr. Salman
yes
Ali.
Mr. Malik please try to resolve this issue and we will join you again till then we have to take other participant paper ID 210 Mr. Salman Ali paper ID 201 okay is there Miss Priyanka Mishra Priyanka Mishra paper ID 292
मलिक सर शो कर रहा है
मलिक सर आप इंटायर स्क्रीन करें और वहां से शेयर करें ये इशू आपकी साइड से है विंडो शेयर करें आप
Share not visible.
अदर पार्टिसिपेंट को कॉल कर लें जो भी उन्हें मिलेंगे देखा
सलमान अली थे ना सलमान अली
लेकिन है नहीं वो आ नहीं रही।
सर ओपन करा देते ना तो सर
ठीक है ओके उनका पीपीटी ओपन कीजिए
इस नाम से वीडियो निकाल Our next participant is Mr. Farooq. This presentation is going offline. Mr. Farooq, you can start now.
मिनिमाइज कर दो स्लाइड शो कर दो
Good afternoon to all. My name is Mohammad Farooq. Today I am here to present on the topic Dynamic Task Scheduling Algorithms for NDC-based multi-core systems, a comprehensive review. In this paper, we have done a review of algorithms which are used for NOC based multi-core systems. So this is the basic outline of my work. First is introduction. Second is the type of scheduling algorithms. Third are the challenges which are faced in multi-core scheduling. Next, we will have a review of dynamic scheduling algorithms used for multi-core systems. Last is conclusion and future work. So first, what is introduction? In introduction, we will start with what are multi-core systems. Multi-core systems are those systems which are having more than one core. Now, as the number of cores increases, the scheduling process also becomes tough. So, scheduling in multi-core processors refers to the allocation of various cores to the task in the task graph. For example, if we have 100 tasks in the task graph, while scheduling, we will assign different number of tasks to different number of cores. So, while scheduling, we have to consider which task should be assigned to which core so that the performance of the system should be optimal. A scheduling algorithm is used to find out a schedule for a set of tasks on the basis of task deadline and resource requirements specified. Scheduling complexity increases in multiple systems due to task coordination across multiple cores. As we have tasks which have coordination between them. For example, T2 is connected to T3 and T3 is connected to T4. So, as we have multiple connections, so while considering the connections, the task should be allocated to various cores. Therefore, this increases the scheduling complexity. Next, we have type of scheduling algorithms. So basically, we have two types of scheduling algorithms: the static one and the dynamic one. In a static one, all the decisions are made before the start of the task execution. For example, if we have 100 tasks, so in static, all the tasks would be assigned to processing codes before the start of the execution. There will be no change in the execution order. While in case of dynamic scheduling algorithms, decisions are made during execution. The next task to be scheduled is decided at the runtime, and tasks can be reallocated if required. So in this paper, we have done the review of only dynamic task scheduling algorithms for multi-core systems. This is the basic classification of scheduling algorithms. First, we have local and then global. In local type of scheduling algorithms, there is only local scheduling. While in global, we have scheduling of all the cores simultaneously. In global, we can further classify into static and dynamic, then optimal, suboptimal, and then heuristic and approximate. Nowadays, meta-heuristic algorithms are also applied on multi-core systems also. For example, PSO and Dean control algorithms, these are also applied on multi-core systems in the recent work. In static, we have suboptimal and optimal. Then in suboptimal, we have another classification of heuristic and approximate. In heuristic, we have list-based classification, cluster-based classification, task duplication-based scheduling algorithms. Let's go to the next slide. What are the challenges which are faced in multi-core scheduling? The challenges which are faced in multi-core, first is load balancing. So while scheduling, we have to consider the load on the different cores. It should not be like that. Some cores are having a higher load and some cores are having a lower load. It should be balanced because that will lead to performance deterioration. Next is dependency management. In dependency management, as most of the tasks are connected to one another through edges, so while allocating the task, we should consider dependency management. The tasks which are connected should be in vicinity, so that data transfer from one core to another core should be faster, or they are on the same core. So that is the way to schedule. Next is scalability. As the number of tasks increases, the scheduling becomes tough. And as the number of cores increases, it also becomes tough. So the scheduling algorithm must be scalable. It should work. Its performance should not deteriorate as we increase the number of cores or we increase the number of tasks. Next is power management. As nowadays most of the devices are battery powered. So scheduling algorithm must take into consideration the power management. Another real-time constraint is meeting specific deadlines. The algorithms should be like that so that the tasks should meet their deadlines. They should not miss their deadlines.
You have limited time, so.
Okay. Next is communication overhead, and the last is fault in communication overhead. We should consider network contention into consideration while developing a scheduling algorithm. These are the review of scheduling algorithms, which dynamic scheduling algorithms which I have done. First one is earliest deadline algorithm. This is also used for multi-core. The objective of this is scheduling.
Can you please share your comparison study? You compare with other ones?
This is my comparison study.
Okay.
This is I have done the review of the previous algorithms. Next is communication aware nearest neighbor. This algorithm schedule on the basis of communication between tasks. The limitation of this algorithm is does not take path or link contention into consideration. Next is smart hill climbing algorithm. This algorithm is schedule on the basis of a square factor, making contiguous regions, and this algorithm is not feasible for real-time task allocation. Next is communication aware migration algorithm. This algorithm schedule tasks by load balancing through task migration. It migrates tasks if the task is not connected. It migrates tasks.
Yeah, please proceed a little bit fast.
Okay. Next,
Please show
we have
Conclude your work.
conclude show you the review that you have done. Just show it in a tabular form. What you have done. What was the findings of each and every
I have
paper?
done
Can
the
you show
review
it?
of scheduling algorithms. What are the limitations? What are the strengths? What are the objectives? What are the features taken into consideration? This is what I have done in my work.
Okay.
In future work, we can develop algorithms which remove all these limitations.
Okay, Dr. Harsh, sir.
Thank you.
Yes, sir. Yes, sir. My question is,
Yes,
have you prepared any comparison table? Have gone through the various
yes,
papers and
I have prepared a table by studying all these algorithms, which include what are the problems in these algorithms, what should be encountered to solve all these problems.
okay. So you are talking about multi-core, right? So
Yes, sir. Thank you for
have
studying.
you done any research on how to get the load of each and every different cores of the thing, or which language you can use to see the load of different cores of the microprocessor?
Load is calculated by considering the number of tasks on the course. If we have higher number of tasks on certain core, and if we having a lower number of tasks on certain core, that
No, no,
having
that
higher
is.
number of tasks will be overloaded.
Have you till now identified which is the language you will use and which is the module of that
Yeah.
language that will be used to find out
I
the
have
performance of
also
different
proposed my one scheduling algorithm for network attention. I have done the code in MATLAB.
coding in
We can
MATLAB?
also
Okay.
we can also use language like C++ and Java for
Okay.
scheduling algorithm
Okay.
for multi-core systems.
Okay. Okay. My
Okay.
suggestion is that there are many other languages like Python and all, and where the latest modules are available that you can also use to see the performance of different codes,
Yes, sir.
and that to be can
As
be represented in the form graphical form as well.
Okay.
Sir,
Okay.
as the work is migrating towards meta-heuristic algorithms. So for meta-heuristic algorithms, we can use Python also. So nowadays, a recent
So,
paper.
due to short time, just I
Okay.
say consider such suggestion also for
Yes,
your
sir.
future work.
Yes.
And Dr. Megha ma'am, if you have any question or suggestion. Hello. Eh, uh, okay, thank you. A good presentation. Now, next, please. Mr. Salman Ali.
Mr. Salman Ali. Mr. Salman Ali, are you there? Mr. Salman Ali, can you hear us? Mr. Salman Ali,
Hello?
Yes, please. Share your presentation PPT.
Hello.
Hello? Hello?
Hello. Am I audible? Can I share my PPT?
Malik Shahzad Ahmed.
Yes. Yes, I'm
Are you
sharing my
there?
PPT now. Yes, yes, madam, I'm here.
So you can
Audible?
start your presentation. Please share your screen.
Yes, I'm sharing my screen right now.
Yes, that's okay now. Please.
Okay. Good afternoon, everyone. My name is Malik Shahzad Ahmed Iqbal. I'm going to present on the topic Sustainable Cloud, an in-depth systematic review of energy strategies in cloud-based systems. In this presentation, I'm going to discuss about the introduction and various existing models for the energy efficiency and some results and discussion taken from from some research papers newspapers. Uh, Everybody knows that the software cloud is computing is pay-per-use model. Now you don't have to set up your own infrastructure. You don't have to set up your own hardware and software. You can use the cloud system and no need to set up your own infrastructure. So this pay per use model and IT service. It is a beneficial, it provides flexibility, it provides scalability, and also it provides access to the resources, multiple resources are used out. But as we know that every road has its own, it means every benefit comes with some drawback. So one of the major concerns in this cloud environment is the energy efficiency. Uh, Although there are some multiple benefits, but due to the energy, there is a problem of energy loss, and this is mainly in the data center. In a survey, it was found that Amazon web server, Amazon data center consume energy that we can provide electricity to more than 1,200 houses. This is very big concern. So nowadays, this is one of the most hot topics of the research to find a solution to minimize the energy consumption in the cloud-based systems. So in this paper, I also studied multiple research papers, and in those research papers, I found some of the existing energy efficient models that are already available, like energy management techniques. These models are some of the software level, some of the hardware level, and the software model basically focus on optimizing energy use through software solutions such as energy efficient algorithm, virtualization, and workload distribution. Energy efficient algorithms. There is one I want to discuss one energy efficient algorithm. Energy efficient routing protocol is one of the protocol that is used to identify the node or the node with maximum energy level. Because if you want to send the data from one VM to another node, and if there are multiple nodes in between, and any of the node is running out of battery, it may die out. And if it is die out, then your complete task will be broken, and you have to reestablish the task. So energy efficient routing algorithm is one of the algorithms that identify the load with maximum energy level, and transfer the data to that path. Although it compromises the quality because it takes more time, but the transfer of the data is confirmed. So there are some existing model like software level and hardware level. In the software level, there is static energy technique and dynamic energy management technique. In software level, it uses static energy management technique. It uses predefined policies and configurations that do not change in real time, such as fixed resource allocation. If we allocate a resource to a particular system and if we fix the resource, then either it is in use or it is not in use, we cannot change the resources allocated to given particular device or particular system or particular node. And in contrast, in the dynamic energy management technique, this method adjusts resource on the current workload demand. If the demand is less, so it can release the resources. If the demand is high, it can take the resources from the other system. It is like dynamic voltage and frequency scaling and load balancing technique. Further, this dynamic uh, energy management is divided in other two parts, that is resource management and virtualization. Resource management is allocation of the and deallocation of CPU, memory, network devices, and storage. And virtualization, it allows multiple virtual machines to run on a single server, or improve that may improve the utilization of the hardware. Also, migration of the virtual machine based on the load and energy efficiency. That is, optimize the energy. So these are some energy existing energy model that I identified in my review paper. Plus, these models are also divided on infrastructure layer based on the application layer, based on the energy management layer, based on the optimization and scheduling layer, and green certification. Infrastructure layer, these techniques are related to the optimization of data center, physical facilities like network equipment. Application level techniques are based on the cloud services like software as a service, network as a service, infrastructure as a service. Uh, Energy management layer is based on the energy monitoring tools. There are multiple tools that monitor the remaining energy and utilize the nodes nodes or devices that have more energy. Uh, and also, from these models, I have identified these are the some data I have taken from the research paper, that the energy consumption of the different different data centers. For example, in timestamp one, server ID is this. CPU 60% usage, memory usage is 50%, disk usage 30%, power consumption 180 watt, and cooling efficiency is 88%. That is the energy saving technique used as the virtual machine consolidation. So
Yes,
in this,
so Mr. Malik, so if as I said, I have a question. If you improve it means on demand hardware will be more. So which factor you consider in this case to reduce the energy or balancing the energy parameter?
I beg for pardon. Can you please repeat your question, sir?
Yes, actually, as I checked in this presentation and you mentioned also, depend on demand for cloud-based hardware, will be matter that how much energy consumption going to happen. So in this case, how this will be work? How you find this study in real case?
Sir, I don't exactly remember it.
Okay,
Which technique is used.
okay. Sir, Dr. Harsh, sir, are you there?
Yes, sir. So, have you identified any now any direction after going through these papers? Have you identified any direction where you will work now? In which
Uh, Yes, sir. I identified the direction that I am working on to find out the algorithm that will identify while transferring the data to different server. I will try to find out the remaining energy level of the node,
okay,
so that I can send the data through the node that have highest energy power remaining, not the minimum.
okay, okay. So you must have already gone through computing. Have you gone through edge computing? This is the latest thing that is being going on in the research. Have
Yes,
you
sir. Edge computing, I'm just started
edge
learning, sir.
computing drastically reduces the power requirement as well as the requirement for the computational power also. That you can
Yes, sir.
also
Yes, sir.
get through your
Yes,
or
sir.
create your
I want
model
to,
to
but
reduce this one.
yes, sir. I am trying to incorporate. I'm also studying on that, sir.
Okay, so is there any conclusion that you have written?
And
Uh,
simple
Then
this is that the
what was the?
based on based on these data, I
Uh-huh.
identified that the average CPU memory usage value, that is CPU usage is 62% and the memory usage is 68% respectively. So there is a chance that we can reduce this total energy consumption. There is a potential for optimizing resource
Okay.
allocation
Thank you.
and reducing idle time.
okay.
Thank you, sir. I think we can.
Dr. Megha, ma'am, if you have any questions, suggestion, please. Dr. Megha. Okay, Malik sir, just I have one suggestion because I got some points. You must mention some balancing issue for energy in different resource. Thank you very much for your nice presentation.
Thank you, sir. Thank you, sir.
Next presentation, please.
So our next presenter is Mr. Salman Ali. Mr. Salman Ali,
Yes,
please
ma'am.
start.
Am I audible?
Yes, yes. Please start
Yes,
your
sir. Thank you,
presentation.
ma'am. Okay, ma'am. I will start my presentation. Ma'am, it is visible to you?
Yes.
Ma'am, my
Yes.
screen is visible to you?
Yes. Yes.
Yes.
Sir, can I start?
Yeah, please.
Yeah.
Yes,
Sure.
sir. Thank you, sir. Good afternoon, everyone. My name is Salman Ali. I am a research scholar of Department of Computer Science, Aligarh Muslim University. Sir, I am here to give my PowerPoint presentation on my paper titled A Hybrid Cryptographic Scheme for Secure Communication. This is the outline of my paper. In first, we have this abstract, introduction, literature survey, background, proposed method, experimental result, and finally we conclude the result. Sir, as we know that the huge amount of data is transmitted over the network, which consists of confidential information. This data is susceptible to various kind of attack, like modification or alteration of data, unauthorized access, malicious attack, and any kind of attack. To address this challenge, cryptography offers a mechanism for ensuring data security via confidentiality, integrity, authentication. This paper introduces a hybrid cryptographic scheme for data security during communication, which consists DNA cryptography and AES cryptography algorithm for two level of security. So this is the purpose. This is the basic idea of my work, in which the input plain text is compressed by improved Hive-made encoding, and this encoding compressed binary data is goes to DNA cryptography. Then DNA cryptography is encrypted through AES algorithm, and finally we get the two-level encrypted data. For the key generation process, we have to use genetic algorithm for the which have the maximum entropy value. So this is the literature survey of my paper, and this is the background of my paper. Sir, the background of my paper consists of four different phases. In first phase, we have improved half-man algorithm. The improved half-man algorithm is used to compress the data. As an example, if we take the example cryptography and convert it into binary, then cryptography consists of 96 bytes. If we apply half-man algorithm, then the cryptography consists of only 35 bytes. So this is a huge amount of reduction in the memory, which provide the maximum optimization of my algorithm. And then we, after applying half-man algorithm, we created heap tree for the word cryptography, which is shown in the screen. And on basis this, we convert the cryptography as a step 3 binary coded 100 as in the last of the my screen. This binary code then converted into DNA form by using DNA cryptography. The pair 00 consists of A, 01 consists of C, 10 consists of G, and 11 consists of T. So the plain text is converted into the DNA form, which is the first level of encryption. For second level of encryption, we have to use AES algorithm. AES is a symmetric key algorithm which is required single key for encryption or decryption. So for generating a key, we have to use genetic algorithm in which our key is of size 128 bit, and the run the genetic algorithm a number of 100 times, and in which 100 keys, which key has the maximum entropy, is used for encryption. The best key is used for encryption, provide the optimized result. And finally, we have to use AES algorithm to encrypt or decrypt our plain text, image text, video text, or audio text, or any other text. And finally, this is the proposed model. This is the step one. Transform the plain text into compressed binary string using enhanced encoding. This binary string converted into DNA sequence according to the table 1 as discussed above, and applied genetic algorithm to maximize entropy for key generation. The key must be of 128 bytes. And finally, we applied AES algorithm, convert the message into 128 blocks, and each block is encrypted due to the AES algorithm. This is the version of AES. This is the encryption part, and this is the final decryption part. A single key used for encryption, single key used for decryption due to the symmetric nature of the algorithm. And this is the result and discussion of my paper. I here only showed two results. This encryption time and decryption time for five different data sets: D1, D2, D3, D4, and D5. There is a experimental setup: DES, 3DS, RSA, Blowfish, ACC, and purpose algorithm. So my purpose algorithm works better in comparison to other algorithm due to the reduction size of the message. And this is the overall version. We have to use AES method for encryption decryption data. And finally, this is the conclusion of my paper. The algorithm we are using utilize the strength of both DNA cryptography and AES algorithm. We utilize GA for the generation of keys, which is used for data encryption and decryption. Additionally, we employ half-man encoding for data reduction and binary conversion. The proposed hybrid algorithm highly secure, requiring fewer resources and less time. It is memory management efficiency ability to do the various data. And this algorithm is very useful for secure communication between IoT to IoT, IoT to cloud, and person to person. And these are the differences of my paper. And finally,
Okay.
thank you. If you have any questions, then you can ask me.
First of all,
So
thank you.
after the reduction of the bits, what uh, uh, is there any disadvantage of reducing the bits, because the existing algorithms are already authenticated and working well?
Sir, sir, if we use the plain text just like a separate plain text, then there is no
Hmm.
significant advantage. If we use video or audio content, then the some amount of data can be discarded or can be mislead. But for the plain text, it is very useful. Or for sensor data, it is very useful.
Okay, so it means that it is somewhat lossy algorithm.
Yes, sir. Some lossy for video and audio content.
Okay, but not for
Yes, sir.
textual data.
Sir, it
Okay,
is very
so
well suitable for image and for plain text.
okay, right. Another question is what is the setup you have used? What
Yes, sir.
configuration of the setup that you have used for evaluating the
Sir,
performance?
I have to use two setup. One is Arduino and Raspberry Pi. Both are IoT enabled setup which consist of multiple sensors. And this is mainly used in Python language and implemented in Raspberry Pi and Arduino.
Okay, so which module you have used for implementing
Yes, sir.
this one?
Sir,
Which
again, sir,
Python
please, sir.
module you have used to implement?
Sir, with Python 3, sir. Raspberry Pi gives their module. It is
Uh,
John Thorney's module. And if
okay,
we have to implement direct on machine, then we have to use Jupyter module. Sir.
Okay, thank you.
okay,
Uh,
okay. Thank you.
Dr. Megha ma'am?
Yes, sir. Am I audible?
Yes,
Yes, sir.
yes,
Yes,
please.
sir.
Yes, sir. You are saying that it is optimized in terms of resources and the time. So have you compared other algorithm with respect to
Yes, ma'am.
yours?
Yes, ma'am. I will show the comparison study. There is a comparison study. This is my proposed algorithm for five different data sets. And we have applied DS, 3DS, RSA, Blowfish, ECC, which
It
is
is
the
talking
secure.
about times,
Yes, ma'am.
but it is talking about time.
Ma'am, it is taking about encryption time, decryption time. Ma'am, but
uh,
it can be utilized for the memory management and used for speed of the system.
and resources.
Ma'am, what is the meaning about the resources? Resources just like
You
memory
you
management and
you means
ma'am,
on which data set you have checked that it is
ma'am,
optimized
this
now. It is
algorithm is
taking
used
less
for.
time or less memory. Hmm?
Yes, ma'am. This I show the open on the we have used five different file sizes: 588, 762, 700, and 1 byte. There's a 5 different file sizes which have to use for implementing our algorithm.
Okay.
Man, only for plain text data, and it can be utilized for image also. But in the case of audio and video, there are some loss of data may be possible.
Okay. Okay, ma'am, any more suggestion?
No, the,
Sir.
the
Okay.
data set that you have to use,
Yes, sir.
Yes.
you have compared with the large data, then only the real performance can be checked. Because for the smaller data, that doesn't affect whether you are taking the large number of bits or smaller number
Yes,
of
sir.
bits.
Sir, I am
That is the only
also
suggestion.
spend my work for audio and video formatting. It's a very, very huge amount of data, and this is my
Okay.
future work for this algorithm.
Okay. Thank you.
Okay, thank you. And thank you, Mr. Salman, for your nice
Yes, sir.
presentation. And
Thank you,
we,
sir. Sir, can I leave, sir?
yeah, yeah, yeah. Now, next
Thank you.
presentation.
Thank you. Sir, thank you. Sir. Thank you very much, sir.
Thank you. You can take it now. Our next presenter is Ms. Kanchan Navle. Ms. Kanchan, please unmute yourself and start your
Hello.
presentation. Yes.
Yes,
Hello.
please share
Am I
your.
audible, ma'am?
Yes.
Yes, you are audible. Please
Hello.
share your topic and please try to wrap up within 10 minutes.
Yes, ma'am. Okay, ma'am. Are you able to see my screen, ma'am?
Yes,
Hello.
please start your presentation. Yes.
Okay. Thank you so much, sir. So, firstly, good afternoon to everyone. Um, Session chair and everyone present over here. It's an honor for me to present my model at this esteemed conference. So my name is Kanchan Namdev and I'm from the Department of Computer Science and Application, Dr. Hari Singh Gaur, Central University, Sagar. And the title of my paper is Machine Learning Technique for Performance Prediction of Scientific Workflow
Sorry for
Scheduling in Cloud
interruption. You
Computing
have
Environment.
yeah, yeah, sorry for interruption. You have
Hello.
7 minutes for yes, you have 7 minutes for your presentation. 3 minute question answer. So make sure you are bounded in time. Okay, please continue.
Okay, sir. Okay, sir. To start with the outlines, I'll start with the introduction and post model, the numerical example, and the result discussion, then finally the conclusion. So to start, so basically collaboration. So basically here we done the collaboration of cloud computing and Q-learning. So this collaboration is certainly creating an environment where machine not only store and process vast amount of data, but it also learn and makes decisions autonomously. This is what the Q learning is for. So this is the whole reason for combining Q learning. Q learning is basically a type of reinforcement learning, and the Q learning enables system to learn optimal scheduling. In the context of scheduling we are talking, so Q learning basically allows optimal scheduling strategies through the hit and trial methods while continuously improving performance over time with a certain number of iterations. So here is the main objective of my model, which is to minimize the make span. Make span is basically the total execution time to complete a set of tasks. Also, I will use some other QoS parameter, quality of service parameters for the analyzement. So I'll start with. Okay, so weighted agency metrics and Q learning are two major algorithms that are used in my model to create certainly find the priority of tasks. So in with the help of weighted agency metrics, basically it is used to generate rewards for the Q table. Q table is generated with the help of this formula which is mentioned here. So here is the numerical example for my model. So as you can see, here we have taken the example of 6 decks mentioned like theta 1, theta 2, theta 3, and theta till theta 6. And then table 1 is basically representing the execution system for each task over certain number of virtual machines with cloud server. For here, for example purpose, I have taken 3 virtual machines and 2 cloud servers. Now next one is how to compute the weighted agency matrix for the proposed model. So here, as you can see that, as you can see here q between theta 1 and theta 2 there is communication time which is 2. So basically weighted agency matrix is something that we created, and we mentioned the weight between the tasks. So between theta 1 and theta 2 we have the communication time of 2, so we have mentioned 2. Similarly we perform for each and every task. Then to find the priority of task, we have calculated Q table. Q table is basically, it contains Q values. Q values are basically the scores we generated with the help of this Q table, Q table formula, where we have the elements like rewards and discount factor and learning factor. So once we generated this Q table, we simply fetch the priority of tasks. So in the initial stage for the computing priority queue, we simply append the entry task that is Q theta 1 in the R priority queue. Then we'll traverse this Q table to compute the priority of the task. So as we can see that Q3 is generating the higher value as compared to the other one, that is Q2 or rest of the task. So then Q3 is appended in our priority queue. Similar we perform till the till the exit task. So what we'll get in the final, we will get our priority queue, which is theta 1, theta 3, theta 5, theta 2, theta 6, and then the theta 4. So after that, simply we have to allocate those tasks on each virtual machine. So so when we allocate these tasks on virtual machine, we got the max span of 23, which is much less, which is lesser than the other heuristic algorithm. In the next slide, I have also discussed the result with the comparison with the other algorithm. So here scheduling is done with the help of EST and EFT time. Now the result discussion. So for the analyzement, I have used 3 workflows: montage, spit, and efficiency with certain data set. For the communication time, I've used certain range. For execution time, there is also a range, and each workflow have three set of tasks. That is for montage, I have 25, 50, and 100. So for spit and efficiency, and for comparison of my proposed algorithm with the other state of arts algorithm, I have used HEFT, CPOP, ALA, and PITS. So here is the final result of the algorithm that are performed. And for the implementation part of my proposed algorithm, I have used Python programming language. And when the result is generated, here you can see the make spend, speed up, and efficiency. Our main objective is to minimize the make spend, and the other parameters that are used, that is speed up and efficiency. As you can see clearly that proposed algorithm is reducing make spend as compared to the other classic algorithm like HEFT, CPOP, ALA, PITS. In each case, for the montage case, you can see that there the make span is 17,065, but for the others, it's above than the is higher than the 765. So for the case of speed and for the efficiency, in each case, make span while computing with the proposed algorithm is reduced as comparing to others. Here's the graphical representation of it. As you can see graphically that proposed algorithm is showing much better result than the other algorithms. This is the case for make span, and for the efficiency purpose and speed up purpose, same we are getting a best result for in the case of our proposed algorithm. Then here's the conclusion of my presentation. So I concluded that the proposed algorithm is proposing way better result than the other classic algorithms. And in the future I can say that we can apply deep learning techniques and more advanced deep learning techniques to generate even more better results. Here's the reference of my
Okay.
paper. And thank you, sir.
Thank you for your presentation. Yes, please, Assistant Chair, you have any question, please?
Uh, my question is, you are saying that you have used a Python programming language to implement this one. So
Yes.
which Python module you have used to implement this one?
So Python
Python module
version
you have.
is Python 3. So first one is NumPy, and to create a cloud environment, I have used BOTO3.
Okay. And how you have
Yes, sir.
implemented this formula that you have
So
created?
which so the Q
The
table
QA
formula.
formula. Ah, yes.
Yeah, are you telling what? Yes, this. So this formula is basically consists of this is the here we have the two constant like state and action or state and action, and this represents our learning factor. Learning factor is basically how much quickly our system is updating the value in a table, in a certain table, and then we have get reward. Reward we are simply getting from the weighted agency matrix, and then comes the discount factor. Discount factor. This is discount factor, like how much better values we are getting. So in a classic way, we just use a 0.1 to 0.9 discount factor value for our formula, and reward is simply generated from the weighted agency matrix, and this is the current state value of Q table. For example, for the initial state, we simply maintain a table with all values are zero, when where all values are zero, and this Q table S dash and A dash are simply the next maximum value for the value in the Q table in a row.
Okay.
Okay.
That's all from my side.
Okay. Dr. Meena ma'am, Dr. Megha ma'am, if you have any suggestion or question, please.
Yes. Is there any drawback of your algorithm?
No, ma'am. There are no.
Hello.
I, I mean, hello, hello.
Hello.
Am I audible, ma'am?
Yes. Yes.
Hello.
Yes. Yes.
Yes,
Yes,
ma'am.
you are
There are no.
audible.
There are no. Yes, ma'am. There are no drawbacks, but I would say that there are certain limitations of it. As you can see, wait a second. Okay, as you can see, ma'am, there's no drastic change, drastic difference between the result that is in the montage task. As you can see, okay, in table we can see that there's no drastic changes in the montage example. So there's limitation is that our value is simply depends on the structure of task. If there are multiple entry tasks, then the output value will be similar to other classic algorithm, but yes, it will be reduced, but not in a drastic way. As you can see in the case of spit, in spit there is a drastic change between the proposed algorithm result and the other results, because there is only one entry task in spit case, but for montage there are multiple entry tasks.
Okay.
Okay. Thank you.
Thank you, Ms. Kanchan. Now, we have next presenter, please. Okay, you may leave. Thank you. Yeah, yeah.
Ms. Priyanka Mishra, please unmute yourself and start your presentation. And please try to wrap up
Yes,
within
ma'am.
5 minutes. Yes.
Yes, ma'am. Am I audible?
Yes, yes.
Yes.
Hello, sir. Hello.
Yes, please share your PPT.
Yes, sir. Actually, sir, there's a request. Actually, Miss Priyanka Jain, Priyanka Mishra is my colleague, and there's some technical issue with her laptop. So, can she use my laptop for the presentation purpose?
Yeah, yeah, no issue. Just open your, turn on your camera and start your presentation.
Okay, thank you so much. Okay, thank you so much. Okay, thank you so much, sir.
Hello, sir. Am I audible?
Yes, please
Yes,
continue.
you are audible.
Start your presentation.
Okay, sir. Yes, my name is Priyanka Mishra, and my dissertation topic is data-intensive workflow scheduling mechanism under precedence constraints using maximum flow network heuristic in cloud computing. I am from our Department of Computer Science and Application from Dr. Hari Singh Gaur University, Sagar, Madhya Pradesh. These are my outlines, introduction, process model, key attributes and program formulation, process mechanism, comparison
Second
analysis,
presentation.
conclusion and future work.
Sorry for just make you one thing. You have 7 minutes for your presentation and 3 minutes for
Yes,
question
sir.
answer. So please be on time. Continue, please.
So emergent technology is the fastest in the concurrence of science and technology and the cloud computing in one of them. This cloud platform is used in field of research such as simulation and modeling, advanced physics, biometrics, system biology, etc. Workflow scheduling is one of the trending research area, and it is formally defined as a mapping of the task onto the available resources, and scheduling problem is known as NP complete problem. These are my proposed model. In this figure, the first component is the directed acyclic graph, which is represent the application model. Second step is my applied heuristic algorithm, which is used to generate the order of tasks that is contained in the directed acyclic graph model. And after these, it is applied into the cloud server. These are N1, M2, and so on, Mn. These are my key attributes, which is used to my algorithm. First is estimated computing time. So these are the formula of estimated computing time. Second one is earliest start time. So it is defined as the time taken by each task on virtual machine, which should take a minimum starting time. It is assumed that every LP task having EST will be zero because anti-task did not any present in task. The EST of non-anti-task can be expressed mathematically. These are the mathematically formula of EST. Second one is the minimum execution time of task TI on the available virtual machine. These are the formula of MT. And the last one is the earliest finish time. It is computed as the follows formula. These are my keywords parameter, which is used to comparison for the another algorithm for my algorithm. First is make string. It is also called a scheduling length. So the minimum value of EFT is also the scheduling length. Second one is speed up. It is defined as the ratio of sum of ECT value for all the tasks of the given directed cyclic graph on the virtual machine, which will take a minimum and a scheduling length. These are the formula of calculating the speed up. Third one is efficiency. So we can calculate the efficiency through the ratio of speed up and number of virtual machine multiplied by 100. These are my proposed mechanism algorithm. So first step is compute residual capacity. So for the complete residual capacity, the formula is the difference of capacity at the flow of the task. Second step is compute attributes. So we can compute all the attributes like EST, AST, ECT for the given directed acyclic graph. Third is sorting. Generate the order of the task for the given workflow in increasing order in the insert priority queue. Fourth step, migration to cloud server. Remove the task one by one from PQ and check the precedence strength is steady
Yes,
or
please
not.
proceed your
And
result and
the last step is yes, sir, yes, sir. So these are the directed acyclic graph which we use to generate the workflow security. These are my comparison analysis. So my proposed algorithm make the result and for the other algorithm HEFT, CPOP, PETS. So these are the comparison analysis for make span, total parallel overheads, speed up, and efficiency for DAG for 10 task and 15 tasks. These are the graphical comparison analysis. This paper proposed a novel approach to workflow scheduling that given better schedule. It is a combined approach with a maximum flow network and minimum distance method. And it has found a new parity attribute known as modified minimum distance. This method uses residual capacity as a communication time between the tasks. This will be help to compute the parity for the task comparison result using two workflow models with 10 and 15 tasks. So that the proposed mechanism give optimal make spin as compared with the well-known heuristic HEFT, CFOP, PETS. Similarly, other QS parameter reschedule and improve result. Thank you, sir. These are the references.
okay, thank you. Uh, yes, sir. Dr. Harsh, sir, you
Yes,
have
sir.
any question? Yes, please.
So what was the experiment? What the environment that you have used? Can you explain it?
So please repeat the question.
Hello.
Hello.
Any
Yes,
simulator
sir.
you have used, or how you have checked the performance?
Sir, we can use HEFT and CPOP algorithm to compare the algorithm.
Okay.
You are not properly audible. Hello.
Yes.
Audio is not very clear.
So we can use HEFT, CPOP, PETS algorithm to compare this algorithm.
Okay.
Actually, audio is not clear.
Dr. Harsh, sir.
Audio is not clear what she's saying.
Okay, there is some audio issue, but please consider.
Okay, the next question can be asked by ma'am.
Okay. Okay. Yes, Megha, ma'am.
So
Dr.
have you
Megha.
tested only single data set or any other also?
Yes, ma'am. We can use this algorithm only directed acyclic graph.
Okay. Any suggestion, ma'am?
So you can experiment on other data sets also. It will prove the
Yes,
robustness
yes,
of your
ma'am.
method.
Okay, Miss
No,
Megha.
ma'am. I
Okay, ma'am.
only work for these directed acyclic graph only.
Okay, Ms. Priyanka, ma'am, I have just one suggestion for your best future research. Please make your
Yes, sir.
presentation to the points and more light so that it's more visible, okay? Okay, thank you very much
Okay, sir.
for your effort. Have a
Thank you,
nice
sir.
day. Paper
Thank you,
ID
sir.
201, paper ID 201, not available here. So you please come in next if you have any audible issue. Okay, ma'am. Okay, sir. Now we closing this session. Thank you very much.
Okay, sir. Thank you. Thank you so much.
Thank you, sir.